My name is FATİH. I will presenting on the topic of the supporting the telecommunication infrastructure with unmanned early vehicles. On this slide, you will find the table of contents section, which outlines the topic I will be discussing throughout this presentation. Let me start by explaining how the UAVs with base station work. First, it's important to understand how signals reach our phones. Signals from satellites in the Earth orbit are received by the nearest base station, which then relays the signal to our phones. For this reason, it's crucial that the base stations are functioning properly. In the event of the natural disaster, such as earthquake, base station can become damaged or destroyed, making it difficult for victims and search and rescue teams to communicate. This is where UAV's base station comes in. These UAVs are sent to the affected areas and act as mobile base station, relaying signals from the nearest functioning base station to those in need. It's worth noting that this technology is just limited to disaster relief efforts. It has also been used in crowded social events such as stadium or rallies. On this slide, you can see the literature review and milestone figure. Studies on UAVs with base station began in the US in the 26 and have continued to this day. One significant contribution was made Wheeler and his team, who proposed an concept of the B number, which refers to the area affected by earthquake. This area is scanned and UAVs are sent accordingly. It can see in Figure 3. On the other hand, Al-Hurani suggests that different regions should be assessed using different parameters for maximum effectiveness. In this case, we need to establish different parameters for maximum effectiveness. So we will first look at three cities and different altitudes. As cities at varying altitudes have different air densities, another factor to consider is the engine power and weight of the UAV. This weight is determined by the engine, battery, and the base station. Accordingly, we took into account areas with different types of human population, ranging from the downtown to urban areas. We conducted result analysis on three different cases. Case 1 examined the radio frequency transmission difficulties in different areas. Figure 7 demonstrated that signal transmission in downtown areas is more challenging compared to the other areas. In case 2, we examined how the total weight affects the takeoff power. Figure 8, the relationship between takeoff power and weight. Using three areas at different altitudes, it showed that the takeoff is more difficult with higher altitudes. In case 3, we compared flight time with total weight. Figure 9 used the same three areas for case 2 and highlighted the factors affecting the UAV's weight. Notably, this graph provided evidence for Figure 8. Our findings suggest that using different types of UAVs in various areas would be more effective. This approach contrasts with the other studies that use the same type of UAV, which may not be as effective. For earthquake zones, a UAV with database is vital. Our study took many different parameters into account, including the physical properties of the UAV and the nature properties of the area where it will be used. The best results were obtained from the comprehensive approach. The last slide includes our references. Thank you for taking the time to listen to my presentation.